All right, we just learned how to make a histogram. And the nice thing about a histogram is it gives us a way of looking at the distribution of a quantitative variable. And once we have a picture of what that distribution looks like, then we can start to describe it and its characteristics. So the four characteristics that we're primarily interested with are the following. So shape, center, spread, and outliers. So we're going to start with shape. And shape actually has two parts to it. So the first part is how many mountain peaks does it have? So if it has one mountain peak, we'd say it's unimodal. If it's got two mountain peaks, we'd say bimodal. More than two is going to be multimodal. And then if it's mostly flat across the top, that's going to be uniform. Now, the uniform one is pretty rare in practice. I've only ever had it come up once in a data set, and that was when I was teaching business calculus, and I gave an exam. I had 25 students in the class, and I had 5 A's, 5 B's, 5 C's, 5 D's, and 5 F's. So very spread out, very inconsistent. It was very difficult to figure out how do I get this class back on track and learning the material. So uniform is pretty rare. Generally, if you see that a flat histogram across the top off of a data set from class, most likely what happened is you highlighted 2 columns of data and you only want that one column that has the quantitative variable that you're interested in. So it does happen. It's pretty rare. So if you ever get a histogram that's flat, you just want to double check that you only highlighted that one column. All right, so these pictures are really great. They're very simple and easy to read, but histograms themselves are maybe a little bit more ambiguous. So I have 4 examples here, and I'd love for you to pause the video for a second and kind of make your best guess at these. But before you do that, kind of one way that we think about figuring out what, whether it's unimodal or bimodal, is if you think about taking a piece of cooked spaghetti, so it's nice and limp and wiggly, and if you were to kind of drape it over the top and let it fall over the histogram, how many mountain peaks would you get if you were just looking at how that spaghetti laid across the top of your histogram? All right, so use that as a tip, see what you can do here, and we'll come back in just a second. We'll talk about these. All right, so hopefully you took a look at those, maybe made your best guess, but let's go ahead and look at these together. So this first one, if I laid that spaghetti on it, the spaghetti would, the first place it would hit is kind of this highest point. And then that spaghetti is going to drape down on the one side. And as it comes down here, there is a little bar that's shorter here, but it's most likely just going to touch the edge of this one and come down. So this one looks like it's going to be unimodal. This second one, if I start kind of where the high piece is, the spaghetti will fall off the one side. And then there's a little bit bigger gap here between these 2 bars that are higher than there was over here. So most likely that spaghetti will dip down a little bit and then come back over the other one. So I would call that one is most likely going to be bimodal. I'm going to actually skip this third one for a minute. We'll look at this one. So if I start that spaghetti at the high point, remember that's cooked spaghetti, so it should be, has a little bit of bend to it. It's probably gonna come across here and kind of fall off this side, and then it'll fall off this side. So this isn't perfectly uniform, but this is pretty close to uniform. I'd probably call this one uniform. And then this one, this third one, this is the trickiest one. So I don't know that they're, without doing some calculations, that you can really eyeball this one. I certainly wouldn't feel comfortable eyeballing it. Do you think if I drop this spaghetti here, it's going to kind of fall off this side? But what it does here is a little, on that left side is a little bit confusing. I don't know if it's going to drop down far enough that it'll come back up and over, or if it's just going to kind of fall this way. So I'd have to do some more calculations on this one. I'd suspect it's probably bimodal, but that one is just a little too close to tell. So generally the ones that I'm going to give you on the homework on the exams are going to be more clear cut like this one is. And I wouldn't give you something like this on the homework or an exam because that one's just too close to tell. Okay. All right, and then the second part of shape is your distribution or your histogram symmetric or skewed? So distribution is symmetric if the 2 halves on either side of the center look approximately like mirror images of each other. So if I can fold that in half and it looks about the same, then we would call that one symmetric. So this picture here, this one is symmetric. If I folded it along the middle, I'd have two sides that look pretty much identical. This one is also unimodal. It's just got one high point. And so a unimodal symmetric distribution is known as a normal distribution. And so we will be looking at this quite a bit towards the second half of the class. So that unimodal symmetric normal distribution is something that we'll visit again. So if it's not symmetric, some other options that you could have to describe it is that it's skewed. So a distribution is skewed if it's not symmetric, and you have one side of that histogram, that tail stretches far off into the distance. Okay, so this picture is skewed left, and the tail, you can see that it drops off pretty quick on the right-hand side, but on the left-hand side, it takes its time meandering down and across. So the tail is on the left side here, and so we would say this one is skewed left. And then the picture on the far right is skewed right. So on the left side here, it drops off quick. And then on the right side, it kind of takes its time meandering down and flattening out. And so the tail is on the right side, which is what makes this one skewed right. Okay, come back in the next videos and we'll look at the other parts of describing our quantitative distribution.